continue with lesson 4.3 if you remember. And so today we're going to look at exact values. And so remember, exact values mean no decimals. So we're looking at fractions only. And so if you notice up here, it says find the exact value of each trigonometric function. And so the first one we're going to look at is sine of 180. And so the best way to get started with these is to think about where is 180 degrees located. And so when I think about that, I know that 180 degrees is located where?
On the x-axis.
On the x-axis. So if I were to go ahead and draw my x and y, I know that 180 degrees will be located right here. What type of angle is 180 degrees? Do you remember what that's called?
Straight?
Starts with the Q.
Oh.
Quadrantal angle, yep.
Yeah.
And so now what I'm going to do, whenever I'm finding exact values, my radius is always 1. And so what I'm going to do here is draw a point out here. And remember, the radius is always the distance from the origin. So the distance from the origin here has to be 1. Now, we know that sine is opposite of our hypotenuse. I can't draw a triangle here. So I'm going to rely on what I learned yesterday a little bit. And if you remember, the location of this point would be negative 1, 0. Right? How are you going to do this? Okay, because it's got to be a distance of 1 from the origin. And if I put a dot here, the coordinates have to be negative 1, 0. So you could have went the other way. No. And so now what I need to do is think about yesterday. If you remember yesterday, we learned another way for sine. Do you remember that? We had sine, cosine, and tangent.
Y, x over y or something?
Sine was perfect, y over r. Remember cosine
X over y.
was x over r. And then we had tangent was y over x. And so I suggested you write those down.
I wrote that.
Because that's just something good to have. And so in this problem, I need to find the sine at 180. So the sine at 180 is going to equal y over r. What is my y coordinate in that point?
0.
0. What is the radius?
1.
1, because remember I said when we find exact values, the radius is always 1. So sine at 180 will be
0.
0. Just for kicks, since we've already drawn this angle out, let's find the cosine at 180. Because cosine we know is x over r. And so x in this problem is negative 1 divided by the radius is 1. So what is cosine? Cosine is negative 1. So on your pink sheet, you already have two answers. You have the sine at 180, which is 0. You have the cosine of 180, which is negative 1. So if you fill those in, we need to think now about tangent.
B 0 too.
What do we know about tangent?
Y over y.
Tangent is y over x. Another way to view tangent, I know that tangent is defined as being sine over cosine. So what I can do is find my sine of 180 and divide it by my cosine of 180. And so the sine of 180 I found was 0. And the cosine of 180 is negative 1. So tangent at 180 will be 0. Now the beauty of this problem is that you've already filled in 3, right? I know that cosecant is the flip of sine. So what's the reciprocal of 0?
Undefined.
Undefined. Now for those of you wondering, if you look up here, if I flip that, I get 1 over 0. So cosecant will be undefined. Secant, what's the flip of negative 1 going to be? Negative 1. So cosecant is CSC. That's the far one. So cosecant is undefined, secant is -1, and then what's cotangent going to be?
Undefined.
Undefined. So there you go, you got a row done.
Oh, crap.
You're fine.
I forgot. Thank you.
You're good. It's okay. Okay, so now, that's one row down. So now what we're going to do is we're going to look at another problem. Tangent of 3 pi over 2. This is only the second problem, guys. That's it. So,
Which is 270.
tangent of 3 pi over 2. So now you have your pink sheet. You've got the radians done. Look there, you've got 270 degrees. And so now I'm going to go ahead and plot that point. And as some of you have already said, that's 270 degrees. So I'm going to go ahead and go down here to 270 degrees. How far from 0 will the exact value always be? 1. So I'm going to come down here and put a point. I know this distance here has to be 1. So what are the coordinates of this point going to be? 0, -1. Now, to find tangent, remember tangent was defined as what over what?
Y over R.
Y over what?
Oh,
X.
X over Y.
X.
Y over X.
So tangent of 3 pi over 2 is y over x.
Undefined.
So in this problem, my y coordinate is -1, x is 0, so the tangent at 3 pi over 2 is undefined. Now, just for kicks, what is tangent's partner?
Okay.
Cotangent. And so in this problem, the cotangent of 3 pi over 2 is going to be the flip of -1 over 0.
It's 0.
So the cotangent is going to be 0. So we're at 3 pi over 2. You have tangent is undefined, cotangent is 0. Since we've already got the diagram already done, let's also do sine and cosine, just for kicks.
You don't even have to do them, you can just look at your tangent, can't you?
Yep, well, kind of. So the sine we know would be y over, oops, having trouble writing, y over r. So in this case, y is -1. So I'm going to do -1 over the radius, which is 1. So what's sine here, folks? -1, very good. What is the cosine going to be then? What is the cosine going to be? 0. Yep. So, because it's going to be 0 over 1 as well.
So, couldn't we have just looked at your tangent and just did that?
Yeah. I mean, pretty much. It's not always going to be the case, though. And you'll see why. All right, so those are the quadrantal angles. Here's another one. Cosecant of pi over 2.
What is SEC go with? Does SEC go with cosine?
So cosecant pi over 2 is what? Where's pi over 2?
I'm looking, oh, that's 90 degrees.
Pi over 2 is 90 degrees. So I'm going to start drawing my graph. 90 degrees is where my angle is now. Here's 90 degrees. What is my distance from 0?
1,
1. The coordinates of this point are what?
0,
0, 1. So they want cosecant. So it would be best to find sine, because I know that cosecant is the flip. So sine of pi over 2 is going to be y over r. So y over r. Y is what? 1. R is 1. So the sine is 1. But remember, in this problem, I want to know what cosecant is. So cosecant is the flip of that. So cosecant will be 1. There you go. There's another thing you can fill in. Okay. Now, looking at that, what would be your cosine? So look at this diagram. What would be your cosine? Why? Cosine is defined as x over r. My x-coordinate is 0, as you've already said, which is perfect. My radius is 1. So cosine is 0. What's cosine's partner? Secant. So what's secant going to be then? Undefined. Good. So you see how this kind of works? You can be doing your homework along with this pink sheet and filling it in and get most of it done.
So if the basic one is 0, then the offset is undefined.
Perfect. Yes. And if you didn't hear that, I'm going to say it again. Okay? What Christina just said is, if the answer here is 0, okay, the partner trig function will be undefined. So in this case, cosine was 0. So secant would be undefined because when you flip it, you get 1 over 0.
If the first one's -1, would it just be -1?
Yep. So now let's go ahead and look at this one, cotangent of -90. So -90 correlates to what? -90 correlates to what positive degree?
270.
270. So that's why we learned about all those positive and negative angles, because -90 is actually down here. So we've pretty much already done the 270 thing. Okay, coordinates here are 0, -1.
So do we have to do it since you just did it?
Well, you have to answer this because this is going to be on your homework. So cotangent goes with what? It goes with tangent. So let's find the tangent. What was the tangent going to be here?
-1 over 0.
Negative y over x, which in this case is -1 over 0. So cotangent has to be what, folks? 0. Good job. So now what happens? So far we've got a pretty good grasp of the ones that are the quadrantal angles. So now we're going to talk about something known as a reference angle. So what happens if the angle is not 90, 180, 270, if it's not on the axes? So this is something that we need to talk about, and that's what is known as a reference angle. A reference angle, here we go, is an acute. So first of all, it's acute, and it's positive. It's an acute positive angle. Your book calls this theta prime. Some other books call it alpha. So if you would look in another book, it might be called alpha. Look like the fish. It's formed by the terminal side of an angle and the x-axis. Pretty important. The terminal side of an angle and the x-axis. And so down here, they give you diagrams. I don't know if you necessarily need to write these diagrams down, but they talk about the different quadrants, how you would draw the reference angle in. And so in this first diagram, I have theta here. Here's the terminal side of the angle. So how we form alpha is we take our terminal side of the angle and we draw it down to the x-axis, and that creates 90 degrees. Okay. So quadrant 2, here is the terminal side of the angle. I'm going to take that terminal side of the angle, I'm going to draw it down to the x-axis, and then this is theta. Now notice there, theta is still an acute angle there. Here is the terminal side of my angle in quadrant 3. I'm going to go ahead and draw that up to the x-axis. So theta is right here. Okay. And then quadrant 4. Here is the terminal side of the angle. I'm going to draw that up to the x-axis. And there is theta right here. Biggest thing you need to know, you always draw it to the x. So you will always make a vertical line. You will never make a horizontal line. So never ever draw it to the y. So now we're going to look at an example. Sketch each angle, then find the reference angle. So first angle I'm going to sketch is 300 degrees. So what quadrant am I in? 4.
4.
So right here. So this is 300 degrees. I'm going to go ahead and draw my terminal side in. 300 degrees. The reference angle, do we now see how it's formed?
Yeah.
We're going to draw this up to the x-axis, and I've created a right triangle. The reference angle will be located right here. And what is the measure of that going to be? 60. Is there anybody that doesn't see where 60 came from?
Is that the answer?
No, that's just the reference angle. We're going to use that eventually. Negative 2 pi over 3.
90 degrees.
Let's go.
Or not, 120.
I start here at 0. The negative means you go backwards. Okay, so let's think about negative 2 pi over 3. Negative 2 pi over 3 is going to put me right here. Now, for those of you wondering, how did she know that? I look at the fraction, 2/3. If I go backwards, this is what fraction right here? This is 1/2, isn't it? If I go backwards, negative 1/2 pi. What's going to be up here? Negative 1 pi. So when I think about 1/2 and 1, I compare the two, and so I know 2/3 falls between those two. So anyway, I got to find the reference angle. Ooh. So what's the measure of that going to be if this is negative 2/3?
It's gonna be right around 60.
What if I want it in radians?
Well, then you just go to your little 60 on your chart. That's pi over 3.
What happens if you can't use that chart on the test?
Use the division.
This is the easy way to think about it. What did I say a whole line is? 180 or 1, right? I've used 2/3.
1/3.
1/3, good. So it's just going to be pi over 3. So view that as half, 1/2, 1.5, and use those. That will help. All right, so now 390 degrees. And we're going to probably call this good when we finish with this one today. This is just sketching reference angles. So first of all, 390 degrees. What quadrant am I in? What?
Actually, first.
First. So I'm going to go around once. Okay. And then I'm going to go how far? 30. So remember, here's my angle. I'm going to draw my terminal side in. What do I do to draw my reference angle?
To the x.
I go down.
To the x.
And what is this angle going to be? 30. Is there anybody that isn't seeing this? Okay, let's see how we do on the pi one. 5 pi over 4, what quadrant?
5/4.
Think about 5/4. 5/4
It's
is
a little
what?
over 1.
It's 1 and a 4th. Yep, right here.
It's a little over, that's like a half.
So it's 5 pi over 4, it's 1 and a 4th. So when we think about this, this is 1 pi,
Oh, you're right.
and this is 1.5 pi.
So it would be
So it's going to be halfway between. Now I need to find the reference angle, which is this. So let's think about that.
45 degrees.
This was 1 and a 4th, as you said, 1 and a 4th pi. That's 1 pi. So what's the pink angle going to be?
45 degrees.
I know, but what in terms of pi?
Oh, it would be,
Pi over 4.
dang it.
Easiest way, you've got 1 and a 4th pi. You've already got 1 pi used, so that has to be pi over 4. Now eventually where we're going to go is we're going to go to finding values at the reference angles. What I need you to write down now is something that's pretty important. Get this down. This is what we will continue with tomorrow. But what that gives you is that gives you all of the positives or negatives for sine, cosine, and tangent. So in quadrant 1, everybody's happy because everybody's positive. In quadrant 2, one person or 2 people are sad. Quadrant 3, 2 people are sad. And quadrant 4, 2 people are sad. So quadrant 1, everything is positive.
It's always good to be positive.
So I'll let you get that down.
Yeah. I just have a few more cameras for
add any more rows in there?
It's not an addition. It's a subtraction when you.
Okay, so we got that down. Okay, I'm gonna go ahead and this is where we're heading tomorrow, cosine of 30. I'm gonna go ahead and let you copy down the lesson. Okay, now,
What was
12 through
yesterday's
58
assignment?
evens. Yesterday was 1 through 8 all from that page. Okay, 12 through 58 evens, what you could be able to do. Okay, we are on page 251. You could be able to do 12, 14, 16, 18, 20, 22, and 24. So you should be able to do through 24 for tomorrow. Suggestion, do that because we're breaking this assignment into parts. Tomorrow we'll hit the next part. 12 through 24 you should be able to do. All right.